In this video, we are going to do these three questions. Well, this figure is part of this question and including one MCQ that's from the chapter Circle, class 10. That includes properties of tangent from same exterior point, radius perpendicular to the tangent at the point of contact. It will also include concepts involved in application of trigonometric ratio. So let's begin with the first question. In this question from the chapter Circle, is given that there is a figure over here and OP is the diameter of the circle with center O. So we are given the length of this OP as it is equal to the diameter. So one thing is clear that if I take this as the radius, let's say if I say this is R over here, that is the radius, then OP is going to be 2R, right? So this is what the information, let's write on what we have just observed, that AO being the radius, say R, then OP is going to be how much? That is 2 times R, that is 2R. Now, if I read it further, we can say that PA and PB are two tangents. Yes, these are two tangents drawn from the same exterior point, that is P, where A and B are the point of contact. What we need to prove here is that this triangle is what? Equilateral, that is APB. I need to join this also. So this is what the triangle we have to prove as an equilateral triangle, that is triangle APB. So let me shed the triangle which they're asking for. We need to prove this triangle as an equilateral triangle. Now the concept that we'll be using in the first part is that you know that these two angles must be equal, right? And what is the reason for this is that we should write down the line joining the center to the exterior point of the tangent is the bisector of the angle between the tangent. Or you may prove these two triangle congruent. You may do anyway. And the second property which we are going to apply is trigonometric ratio in this triangle. In this triangle, we are going to apply the trigonometric ratio. So let's figure out. This angle is 90 degree. This is because radius is perpendicular to the tangent at the point of contact. So let's say if I first consider this triangle, that is triangle AP or AOP is same as APO, and we need a relation. We know this length as R and this being 2R, so we need a relation from between the perpendicular and the hypotenuse. So that clearly we'll be taking sine or cosec. So sine theta, well, theta is clear in the diagram, is what? Perpendicular, which is OA, over hypotenuse, which is OP. This is sine theta is equal to OA, as per we can see that it is R. So I'll replace this by R and OP as 2R. R get cancelled and we got sine theta as how much? Half. And we know that sine 30 degrees half. Sine 30 degree is half. So from here we conclude that the theta is how much? 30 degree. Now check for these angles. We have got this as 30. So these two angles are clearly, so it will be 30 again. This results to give you how much? This whole angle as 60 degree. So this angle, this whole angle is going to be how much? 60 degree. Now once again, look into this triangle. Here, it is an isosceles triangle, right? Where PA and PB are tangents. So let's write on this part. So PA is equal to PB, right? That is tangent from same exterior point. So what we know that when in a isosceles triangle, if two sides are equal, then the angles opposite to these sides are also equal. That means we can write this angle is equal to this angle. So let's say if I write this angle as say x and this also as x. So what we can say over here, that is x plus 60 is equal to 180. So that implies 2x is equal to 180 minus 60 is 120, and this x is also 60 degree. So now see here that we have proved this x also as 60 degree. These angles also we proved 60 degree. So this is 60 and this is also 60. So therefore, we can say that in this triangle, we have all three angles as 60 degree. Therefore, it is an equilateral triangle. So you may write down that in a triangle, when all angles are equal, this is an should be considered as an equilateral triangle. So that's how we will do this question. In this question, it says from a point P, which is at a distance of 13 centimeter from a center O of a circle of radius 5 centimeter, pair of tangents PQ and PR are drawn to the circle. So let's first begin with making a circle, and then we are going to draw two tangents from an exterior point. Let's say this is one. PA and PP are two tangents drawn from the exterior point. Is PA or no, it's PQ and PR, right? These are the two tangents drawn. This is P is the exterior point. So PQ and PR are the two tangents. And further, it's given that the line joining the center to the exterior point of the tangents, that means I need to join P with O, right? This is given as how much? 13 centimeter. This is 13. Further, the radius, I can join the radius over here, and the radius is given as how much? 5 centimeter. So this is 5 here, the radius, and this is 5. Well, clearly O is the center of the circle. Now, what is the question here is to then calculate, right? We need to calculate the area, and the area here is for the area for this quadrilateral PQOR, right? So we need to get the area of this quadrilateral. Now for that, we are going to use this property, that is radius is perpendicular to the tangent at the point of contact. So this angle is going to be 90 degree. Now, first thing that we know that since it is a right angle triangle, we can apply Pythagoras theorem. In fact, you know that 13, 5 and 12 are Pythagorean triplets, where 13 being the hypotenuse. So we get the length of this PQ as how much? 12 centimeter. Now from here we can find the area of this triangle, and that's by half base into height. So we say that area triangle POQ is going to be what? Half into base. Clearly base I can take 12 and the altitude as 5. So I can reduce this, and I got this as how much? 30 centimeter. Yeah, it's centimeter square. Now what we know that similarly the area of this triangle is also going to be same. So we can just double it to get the area of this quadrilateral. So area of this quadrilateral is what? 30 multiplied by 2, that is equal to 60 centimeter square. That's how we will do this question. In this question, it says two chords AB and CD of a circle intersect at E, and the length of AE, BE, CE is given, right? And what we have to find out is the length of DE. So clarity will come only when we make the diagram. So I first made a diagram, and then we have chords A, B, C, D intersecting. So let's say if I make this being AB as the chord and the other chord CD, and this point of intersection is given over here as E. So this is AB, this is CD, and let's say E is the point over here. Now we are given the length of AE as 2 point, and it's not up to the scale, right? Just 2. This is 2.4. BE, B is 3.2. CE is CE, yeah, that's 1.6. And we have to get the length of this DE. This is what we have to determine. This is what. Now we are going to use the property over here is that alternate segment, and for that I am going to join these. I'll join AC and BE. Now what we know that angle in the same segments are equal. So these two angles will be equal, right? Say if I name this as angle 1 and angle 2. Similarly, these angle 3 should be equal to angle 4. So I can write over here angle 1 is equal to angle 2 and angle 3 is equal to angle 4. And the reason you should write angle in the same segment. Angle in the same segment. Same segment. Now check here. Now, can we say that these two triangles are similar now? Look into these two triangles. We have proved two angles of these two triangles equal. So therefore, by a congruency condition, we can say the triangles are similar. So I'll write the triangle here, that is A, E, C. And what does A corresponds to? A corresponds to D. So this is D, E corresponds to E, and C corresponds to B. So here the triangles got similar. So we can write their sides as proportional. So that is, say, first two letter here is AE over DE. As you know, AE corresponds to DE and CE corresponds to EB or BE. Now here we just need to plug in the value. I can see the length of from here. We know the length of AE is how much? AE length is given as 2.4. Length of DE is what we have to determine. So let's keep it DE. CE length from here. CE is how much? 1.5, 1.6. And EB is 3.2. Yeah. So now before doing cross multiplication, I can see this is reduced by 2 times, right? This is 32, 62 times. So now by cross multiplication, we get DE as how much? 2 multiplied by 2.4. That results to give you DE as 4.8 centimeter. Right. So this is what is the length of, this is what we have to determine, that is DE, and we got DE as 4.8. In this question from the chapter circle, it says triangle ABC. We have AB is equal to AC. So let's make a triangle first. I made a triangle over here, keeping in mind that the length of AB is equal to AC. So these two sides are equal. Further, he says interior of the circle of if the interior of the circle of triangle ABC touches the side AB, BC, CD at these points. So that means we have to make a circle which touches all three sides. So that way, all right. So we can see that this is what the point of intersection AB at D, BC at E, and AC at F. Now check what we have to get finally to prove that this E bisects BC. That means we need to prove that. To prove is what? To prove here is that BE is equal to EC. Now we are going to apply the concept of tangent from same exterior point. So from here you can see, if I apply the tangent from same exterior point, we have this is equal to this is equal to this, and this is equal to this. So we can write it over here that we have AD equals AF and BD equals BE. Also we have CE equals CF. Now we will be using this in order to prove that E bisects BC. Now for that we will be beginning with this thing that we have AB is equal to AC given, right? AB is equal to AC. Now I'm going to split AB, right? What I can write AB as? We can write AD plus BD as we are going to apply this. And similarly, AC can be split as AF plus CF. So from here you can see that this AD is equal to AF, right? This AD is equal to this length AF. So if they are equal, we can cancel them. So if this get cancelled, we are left with BD is equal to CF. Now what is BD is equal to? We can replace BD with BE. And what is CF? CF is equal to CE. So I can say this is what we needed to prove here, right? So we proved it. Now let's come to the next question.